This video, we are going to look at the Python code for the support vector machine model. In order to understand support vector machine model, practically, we have taken a data set on patients. So this data set is obtained from the Kaggle website. In this data set, we have different factors of a patient, and depending upon the different factors, we are trying to predict whether the patient should be prescribed a particular medicine or not. Now, without further ado, let's jumpstart into the coding of support vector machine model. Import numpy as np, import pandas as pd, import matplotlib.pyplot as plt, import seaborn as sns, import warnings dot filter warnings so that we can filter out all the warnings. We are going to ignore all the warnings. Now let's run this code. So we have successfully run this code. Now let us upload our dataset, or let's import our dataset. So df is equals to pd dot read underscore csv. Now let us look at the head of the dataset. So df dot head. So this is what our dataset looks like. So we have the age column, we have the sex column, we have the blood pressure column, and we have the cholesterol column, and we have the sodium to potassium column, and the final column is the drug, which is what we want to predict depending upon all other features. Now, if you look at this, can you apply SVM model as it is? No, right? Because over here, a lot of data is non-numerical in nature, and it is very difficult for our machine to understand non-numerical data. So we'll have to convert all these non-numerical data into numerical data. How are we going to do it? There are two ways. One is one-hot encoding, and one is label encode. In my lectures for EDA, pre-processing, handling of these non-numerical data, we had studied that one-hot encoding converts everything into zero and ones. There is nothing else. The problem with one-hot encoding is that it increases the dimension of our data set, which makes our life much difficult. So, a better alternative is label encoding. In label encoding, it uses the numbers 1, 2, and so on, and we do not increase the number of columns, so the number of dimensions do not increase. So let's go on with label encoding. Before that, let's look at the info so that we get an idea of which all columns should be converted from non-numerical to numerical. So let's look at the info. So we have around 200 entries, and age is integer, sex is object, blood pressure is object, cholesterol is object, and drug is again object. So we'll have to convert sex, BP, cholesterol into numerical columns using label encoder. So from sklearn dot pre-processing, import label encoder. Le is equals to label encoder. Let's create an object of label encoder. Df. Now the first column which we want to encode is your sex column. So you write sex is equals to le dot fit underscore transform df sex. I hope you have not forgotten why we have written a statement like this, because fit underscore transform does not have an in place equals to true parameter. So whatever changes happen, it becomes very temporary in nature. But we want the changes to be permanent in nature. So we'll have to reassign the values onto our column. Similarly, we can work around with cholesterol, or let's say BP is the next one. df BP is equals to le dot fit underscore transform df BP. Next is cholesterol. Cholesterol spelling, you may make a mistake, so it's better you copy paste it. Is equals to le dot fit underscore transform, and last and final it's drug. df drug is equals to le dot fit underscore transform df drug. Now let's run this code. Now let us look at the head of the data set. df dot head. So all your columns are now numerical. All the non-numerical columns got converted into numerical. Now it is easy to apply our SVM model. Now when we are getting into modeling, the first step is to define the x and y. So over here our dependent variable is drug. That is what we want to predict. Depending on what? It's depending on your independent variables like age, sex, BP, cholesterol, potassium and sodium. So our x is equal to df dot I log. I need all the rows. I need all the columns except the last column. Dot values. Y is equal to df dot I log. I need all the rows, but I only need the last column. So we get it like this. Now let's run this code. So we have divided our data set into x and y. After dividing the data into x and y, we will have to train test split. That is, divide our data set into training data and testing data. So from sklearn dot model underscore selection import train underscore test underscore split. So x train, x test, y train, y test is equal to train underscore test underscore split x comma y test underscore size is equal to zero point 0.2. You can take the test size according to your wish. Random underscore state is equals to 0. I'm just stating so that I can, my answers and your answers are going to be the same. Now we can build our model. So from sklearn.svm, we are going to import SVC, that is support vector classification, because we know that support vector is used for both regression and classification problem. From sklearn.svm import SVC. Now we'll create an object svm is equals to svc. Now what are we going to do? We are going to fit this model. svm dot fit x train, y train. Finally, we are going to predict ypred is equals to svm dot predict xtest. Now let us run this code. So our model is ready, but just building a model, is that all? No, we have to find the accuracy. We have to see how good is our model. So from sklearn dot metrics import accuracy underscore score classification underscore report confusion underscore matrix. Okay, so print f string accuracy, its accuracy underscore score y test y thread. Print string classification report classification underscore report y test y thread. And finally, print f confusion matrix confusion underscore matrix y test comma y thread. Okay, so now we are kind of done with our modeling. Now let us look at the accuracy score. So our accuracy is 82.5. What does this imply? So 82.5 times we are correctly predicting the proper drug which has to be actually given to that individual. That's a pretty good score, but not a very good score in the medical sciences because you want the accuracy very close to 1. You do not want it accuracy at 82.5 because over there it's a life threatening situation. So depending upon the different industries, the accuracy scores change, the p values change. So everything is very industry specific. So over here we cannot actually adopt this model because accuracy is high, but in a medical context you cannot have such low accuracy. And here you have your confusion matrix and you have your classification report. So in your classification report the data is small, so you cannot generalize this to a greater extent. So the values may be 1, which shows 100% accuracy when we are looking at drug 1, but that is not the case. Our data is small, so there is a chance that these things are 100%, but we have to take everything with caution. So this is the way we have applied the support vector machines in order to predict which drug to be prescribed to a patient. I hope this practical example is clear for one and all. Do like, share, and subscribe to the Ecotechie. If you have any queries, please feel free to post it in the comment section. Thanks for watching.